One of the great tropes of the world of science fiction is the concept of alternate dimensions, a concept that makes its way even into the question of UFOs, but also fundamentally in some of the most prominent theories of physics. The idea is simple. In the world that we perceive, we can move through space in any direction we want, up, down, sideways, no matter how you orient your starting position. This is the three-dimensional world. It's also believed that there is a fourth dimension, time, which we invariably travel forward through. The question is, are there yet other dimensions we cannot so readily perceive? It's worth noting here that time viewed as a dimension is linked specifically to Einstein's relativity. Our motion through space is also motion through time. It takes time to cross a distance, and the conditions, really the speed at which you are traveling, affects the rate at which time passes in different frames of reference. This is the infamous time dilation effect, where time passes at a different rate in the frame of someone traveling at high speed in a starship versus someone sitting out in space watching the starship pass. Of course, this leads to paradoxes, such as the twin paradox, where one twin gets on a starship and heads off at high speed, only to return and find themselves at a different age than their twin. Because of this, it stands to reason that time is also a dimension, but that creates a new question. Are there even more dimensions, and could they allow for different kinds of motions that we are unfamiliar with? To begin to think about this, one helpful way to illustrate it was famously done by Carl Sagan in his television series Cosmos. He asks the viewer to think of living on a two-dimensional surface, a sheet of paper. You could move forward or backward, side to side, but yet cannot move up and down. As a two-dimensional being, you may not even be able to conceive of up and down. It isn't part of your worldview. But this is where it gets disturbing. A three-dimensional creature looking down on you could pluck you out of your world into the third dimension, and then set you back down, which would have the effect of teleportation. Such a creature could see your insides from above. And if the third-dimensional creature entered your world, you would see them as a line, a slice of them, without seeing the whole picture. But there are further weird questions that could be asked. So say in your 2D world you spoke. Would the sound of your voice be confined to your two dimensions, or would it leak into a third dimension? Could the three-dimensional creature looking from the outside in eavesdrop on your conversations? And here is where this gets interesting. In your 2D world, you actually would have a way to figure out the answer to that question, and that in turn would tip you off to the existence of the third dimension. Here is what the 2D scientists would do to try to figure this out. If you take several recordings of exactly the same sound and play them from different distances at identical volume, you would be able to tell how loud they are when they reach you from those distances. That tells you how the sound is spreading out. You could work this out. If it spreads like a circle, then it is a phenomenon solely of your two-dimensional world. But if it's diluting over 3 dimensions, you would see the difference. Well, something like this can be done in our 3-dimensional world by our 3D scientists. We know that if there are other dimensions that are large, not microscopic, then nothing is diluting into them. If there are such dimensions, nothing from us is leaking to them. They aren't affecting our particles, to put it another way. But there could be very small dimensions. These are usually explained as curled up dimensions, and they effectively would be microscopic. This would mean that any effects those have on our forces and particles would be diminishingly small. Interestingly, whether there are tiny curled up dimensions is in fact testable in another way. Here comes the particle colliders, such as the Large Hadron Collider at CERN. If you collide charged particles at high speed, you can tell if there is an effect from another dimension. Long story short, the test has been done for the strong, electromagnetic, and weak forces, and there was no observed evidence for other dimensions from any of them. What hasn't been done, however, is gravity. Once again, the plague of gravity on small scales being incredibly weak and hard to measure rears its ugly head. So far, this can only be measured down to micron scales, which isn't saying much. That's enormous compared to an atom. So far, though, from what can be measured, there is still no evidence that gravity is leaking into another dimension. But who knows what's happening on smaller scales we can't currently measure. Another problem here is what we don't know. When you don't know something, you realize you may not know how to look for it, and that's the problem here. What is the geometry of any extra dimensions? What happens if those dimensions only affect gravity, and do so only on a very small scale? No one knows, which means other dimensions cannot be completely ruled out. But then we have string theory. String theory, if it's correct, which is a big if, predicts more dimensions. What flavor of string theory determines just how many, but one common one is 10 dimensions of space, 1 dimension of time. This, however, does rain on the parade of science fiction scenarios or ideas of trans-dimensional travel and so on. The large dimensions needed for that sort of thing have basically been ruled out, because as I mentioned before, we know how to detect them if we can't normally perceive them. If what's going on in our 3D world isn't leaking out, then it stands to reason that you can't get in your dimensional ship and leak yourself into another large dimension, and then leak back out of it. It does not appear that the universe will let you do that, if indeed those dimensions exist. But if they do, they can't be accessed. But herein lay some monsters. It's often brought up that the phenomenon of quantum entanglement seems, on its face, that it might be accomplished through a curled-up dimension that has no distance. That two particles somehow message each other instantaneously of a state change. But one interesting hypothesis floating around out there is that the messaging does not occur through an unknown dimension, but through our fourth dimension, time. In other words, one particle references its own past when it was first entangled with the other particle, and by messaging the past, the effect occurs. That seems weird. It's backwards time travel of a sort. Useless backward messaging that doesn't contain meaningful information. But if it's correct, it would mean that the past is still tangibly back there somewhere. But ultimately, we don't know. What we do know is something that I find a bit spooky. So two of the greatest overarching mysteries of physics are time and gravity. We do not understand either one of them completely. We just observe them happening. But here's the weird part. They are linked somehow. So remember back to time dilation that I mentioned as something that happens when you go very fast in the universe. In other words, it's a product of acceleration. This is described by Einstein's theory of special relativity. It deals with the effects of speed. But then comes the great elephant in the room. At the time, over a century ago, when Einstein was formulating special relativity, he wasn't alone. There were a number of other scientists circling the drain on that one, because evidence of it was being seen. Einstein just published first. What no one other than Einstein was doing, however, was the other half of relativity, which is general relativity. General relativity deals with gravity. It doesn't tell us what gravity is, only what it behaves like. A warping of space-time by matter. That describes how it behaves in the world of the large. But there may be more to it, which is why some physicists, including Einstein during the latter 30 years of his career, have looked for a quantum theory of gravity to no avail. But here's where that gets weird. So gravity also dilates time. The reason is that gravity also acts like an acceleration, meaning that as you're watching a meteorite falling until it whacks the ground, you see its acceleration, its motion. But once it hits the ground, or you sit there on your chair, you and the meteorite are still held in place by gravity, which equates to you accelerating still. You're just being stopped by the ground. But gravity is still pulling on you as an acceleration, and thus that still affects time. Why acceleration of any flavor is so important is a huge unknown, but it is what it is. But back to dimensions. There's actually another idea regarding other dimensions, that they could have particles of their own, and so on. But one interesting idea came over 40 years ago. It was published by Chodos and Detweiler and suggested that our universe might have arisen from a 5-dimensional framework, 1 of time, 4 of space instead of 3, and the extra dimension is missing as far as we can tell. This actually did not come from string theory, but rather general relativity. The problem is that the metric this is based on says that space can't expand the same in all directions. But observations show that it is, so out goes that hypothesis, except for one thing. It actually predicts that over time, the missing dimension would have contracted and become very small. In fact, so small, we probably cannot ever observe it. But long story short, if you had this shrinking dimension, it actually does give a view of the universe that looks a lot like what we have in other ways, and answers some open questions. Maybe, maybe not. Another option is that dimensions we see are actually a phenomenon of a boundary. But the universe as a whole has more dimensions that aren't reaching that boundary. Think of the universe like an expanding balloon. You're on the surface, but what's going on inside the balloon is not readily evident because you're on its boundary. This is where the famous ideas of a holographic universe come from. In short, it has interesting features mathematically, but again, gets into string theory, which I think anyone that watches a channel like this knows has its problems and objections, and suffers from being extraordinarily hard to test. But the problem is we have no evidence for any extra dimensions at all. They are an exercise of equations, ultimately, and everything we've done to test the idea out has come back negative so far. Basically, in some cases, adding in an extra dimension, or many of them, may answer some questions in principle about the universe that are hard to answer otherwise, but the universe also makes no promises to make getting answers easy. And the math ultimately describes the universe as best we can. But when used to predict how the universe is, it gets more shaky and prone to biases. The universe so far can be expressed and described by math. That's convenient, but also misleading, because the universe itself is not operating on our human math. It isn't a calculator. It just lets you describe aspects of it with one. Thanks for listening. I'm futurist and science fiction author John Michael Godier, currently eyeing the two-dimensional sheet of paper world suspiciously. Sagan made it seem like our 3D world would be gods to the 2D flatlanders. We could pluck them out of their world and look at their insides from a bird's eye perspective. The birds again, now they need to be eyed suspiciously, but I digress. I do not think Dr. Sagan ever considered how a 2D world can give one a paper cut. Revenge of the flatlanders indeed. And speaking of cuts, I'm wearing a band-aid as I nicked myself with a cooking knife yesterday. Just a minor cut, but guess what I was slicing? A lemon. There was much anguish in the kitchen yesterday, I can tell you. And be sure to check out my books at your favorite online book retailer and subscribe to my channel for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.